I've always been captivated by the mysteries of the cosmos, and black holes. Black holes are perhaps the most mysterious of all. These cosmic giants, born from the death throes of massive stars, challenge our understanding of space, time, and the very fabric of reality. In the next few minutes, we'll embark on an extraordinary journey to the edge of human knowledge, peering into the abyss of a black hole. What secrets might we uncover? What mysteries might we unravel? Black holes, those cosmic behemoths, are born when massive stars collapse under their own gravity. As NASA's research shows, when a star at least 20 times more massive than our Sun reaches the end of its life, it implodes with such force, such incredible force, that not even light can escape its gravitational pull. The result? A black hole. A region in space where the laws of physics as we know them break down. But where does a black hole truly begin? That's where we encounter the event horizon, a boundary of no return. Kip Thorne, in his seminal work Black Holes and Time Warps, describes it as the edge of the black hole's influence. Cross this threshold, and you're trapped forever in the black hole's embrace. It's a cosmic point of no return, where even light waves bend back on themselves, unable to escape the immense gravitational pull. Can you imagine a force so strong that it can capture light itself? As we approach a black hole, the laws of physics reveal their most extreme consequences. Tidal forces. The same forces responsible for ocean tides on Earth become so intense near a black hole that they can tear apart stars and planets. NASA's studies show that this process, aptly named spaghettification, stretches matter into long, thin strands. Imagine being pulled apart, atom by atom, as you fall towards the black hole's center. It's a fate that awaits anything that ventures too close to these cosmic monsters. But what lies at the heart of a black hole? According to Einstein's equations of general relativity, at the center lies a singularity, a point of infinite density and zero volume. It's a concept that pushes mathematics to its limits, a place where space-time itself breaks down. Yet, as Stephen Hawking's groundbreaking work suggests, black holes aren't entirely black. Through a process now known as Hawking radiation, black holes can slowly evaporate over unimaginably long periods of time. But how long? How long would it take for a black hole to completely disappear? As we delve deeper into the nature of black holes, we find ourselves at the intersection of two great pillars of modern physics, general relativity and quantum mechanics. This collision of theories gives rise to mind-bending paradoxes. The firewall paradox, as discussed in Scientific American, suggests that the event horizon might be a blazing wall of energy, contradicting Einstein's principle of equivalence. But how can this be? How can we reconcile these seemingly contradictory ideas? Then there's the infamous black hole information paradox, a conundrum that pitted Stephen Hawking against Leonard Susskind for years. If information can't be destroyed, as quantum mechanics insists, what happens to the information about objects that fall into a black hole? This paradox, this fundamental question, strikes at the heart of our understanding of the universe, challenging us to reconcile the seemingly irreconcilable laws of nature. It's a puzzle that continues to baffle, to perplex even the greatest minds in physics. For decades, black holes existed only in theory and mathematical equations, but in 2019 we saw the Unseeable. The Event Horizon Telescope, a global network of radio telescopes, captured the first ever image of a black hole's shadow. This monumental achievement, published in Nature, marked a new era, a new chapter in our study of these cosmic giants. But what did we really see? What secrets did this image reveal? Well, we're still trying to figure that part out. The quest for a quantum theory of gravity, a unified theory that could explain the physics inside a black hole, remains one of the greatest challenges in modern science. As we peer into the depths of these cosmic enigmas, we're reminded of how much we have yet to learn about the universe and our place within it. What other mysteries might black holes hold? What fundamental truths about the nature of reality might they reveal? As we conclude our journey into the heart of black holes, we're left with a sense of wonder and curiosity. These cosmic giants, once mere mathematical curiosities, have become a focal point in our quest to understand the universe. They challenge our notions of space and time, pushing the boundaries of human knowledge. In the vast cosmic ocean, black holes remain beacons of mystery, inviting us to explore, to question, and to dream of what lies beyond. What will we discover next? What new horizons will we reach in our understanding of these fascinating cosmic phenomena?